Alright, so we're going to do 3 and 4. And it is going to be easy because we're going to follow the way. The way of doing physics. Man, I'm running out of room here. Okay. Alright, a beam of electrons moves at a right angle to a 0.6 Tesla field. The electrons have a velocity of 2.5 times 10. So that should be 2.5 times 10 to the 7. So just, mentally note that. 2.5 times 10 to the 7. Man, that threw me off. So this times 10 to the 7. Yeah, there we go. Meters per second. So that's our velocity because it's meters per second. What force acts on the beam of the electrons at an angle of 45 degrees of the field? Okay, so as we always do, every question, before we freak out, we write down what we got. So I see first off the magnetic field because it's in Teslas, right? So I'm going to put B equals 0.6 Teslas. Cool. Sort of showing up. Perfect. Electrons have a velocity of this. So next I'm going to put velocity equals 2.5 times 10 to the 7. And finally, something that they don't really tell us necessarily is it says electrons, right? So electrons have a certain charge. And you flip back a page, and you can look this up on your constants on your formula chart anyways. So if we look here, we see that? Yeah. This few pages back. This is a proton, but protons, electrons, same charge, right? Where are we at? Yeah. So our charge should be... Where am I at? I'm losing it. 1.6 times 10 to the 19. So that's our charge. Charge is in Q. 1.6 times 10 to the 19. Awesome. So now that we have that, what does it want us to do? What force? So that's F. F equals, we don't know, right? So again, we're going to look for a formula that has all of that stuff. So you can either go back a page. I'm not going to flip back a page, but find the formula, right? So it should be force equals charge times velocity times our field, right? And that's everything that they talked about. So now we plug it in. Awesome, because they leave out the main thing we're trying to find. So force equals, my charge is 1.6 times 10 to the 19, parentheses that. My velocity is 2.5 times 10 to the 7. That was a misprint, so that's times 10 to the 7. And my field is 0.6. So, let me see if I can do this in my calculator. See if it works. Open parentheses. 1.6. Ooh, okay, this might work. Times, hold up, times 10 to the 19. Okay. What do I, close parentheses, right? Times, open parentheses, 2.5 times 10 to the 7. I'm obviously using a phone calculator, so we'll see if it works. Times 0.6. Okay. Enter. Infinity. Okay, well that didn't work. Well, you're going to do it on your calculator. You'll get a better answer. Obviously, it's not infinity. I got the key anyway, so whatever. Alright, so our answer should be, what you should have got is 2.4 times 10 to the minus 12. I was thinking about bringing the calculator home, but I'm like, I won't need it. Of course, now I need it. Alright, so that's our field. So that's question 1. Remember, we always do one question at a time. Next question says, what force acts on the beam of electrons if it moves at an angle of 45 degrees? Same thing. So we take our force, and we just multiply it. So we got 2.4 times 10 to the negative 12. And then we multiply that by sine of 45. All right, I'm going to redeem myself. Here we go. Open parentheses, 2.4 times 10 to the... Where's the negative button? Negative 12. Okay. Let's see if that works. Times, open parentheses, sine 45, close parentheses, enter. Ooh, no. Oh, perfect. So I did get it. So our new force should be... this is the force at an angle of 45, by the way. 1.7. I rounded this. You see my calculator? Oh, there you go. 1.7 times 10 to the minus 12. So that's our second answer. So pretty easy stuff. You plug it in, you finish it. If they want an angle, you just multiply your answer by the sine of the angle. Whatever, right? All right, so moving on. Let's do number 4. Same deal. So we have, I'm going to skip the beginning stuff. So we have our Teslas, 0.003 Teslas. That's our field, it's B. We have our proton. So our proton charge should be, that's Q. Q is charge. 1.6 times 10 to the minus 19. And we have our velocity, 5 times 10 to the 6. And we want the magnitude and the direction of the force. Force is F, right? So, same formula. Write the formulas over and over. I know it's like, well, I have it in the previous question. Nah, who cares? Write it again. It's always good because if you backtrack, I make mistakes constantly and I can look and be like, oh yeah, I did this. Easy, right? So, force times, just plug it in. 1.6 times 10 to the minus 19, parenthesis that. 5 times 10 to the 6, parenthesis that. And 0.003. Alright, should be easy. Here we go. I'm plugging it in. 1.6 times 10 to the minus 19 over, close, open, 5 times 10 to the 6, over, close, open, 0.003, bam, oh no, bam, close, boom. 2.4 times 10 to the minus 15, perfect. 2.4 times 10 to the minus 15. So we got our answer. Awesome, very good. Okay, what is the magnitude and the direction of the force? So we know from our reading, unlike gravitational force or electric force, magnetic force is perpendicular to the plane formed by the field and the moving charge, and is greatest when the magnetic field and the current are perpendicular to each other. So, what does that mean? We know they say from the problem that it's moving from right to left. Alright, so with that being said, because the force is right to left, the magnitude in the direction, the direction is going to be perpendicular, which is going to be up, right? So the direction on number 4 is up. So, there you go. 3 and 4 are done, and head to the next video.